Okay, so here we have a lottery game in which contestants pick 5 numbers out of the list 1 through 40. So one lottery ticket consists of a 5-number group out of the group of 40 possible numbers. And to win, all 5 numbers have to be correct in any order. So this is very important here. This tells us we're dealing with a combination. So combination of the correct 5 numbers. So what's the probability that you will win? Okay, so probability of a win. By definition, this is the number of ways you could win divided by the total number of ways you could play. Question is, how many ways can you win? Well, a winning ticket has to consist of all 5 of the correct numbers, so there's only one winning ticket. So number of ways to win, that should be 1. And total number of ways to play, or the total number of outcomes of this particular experiment, well, how many ways can we pick 5 numbers from a group of 40 if there's no repeats and order does not matter? Again, that's a combination. So down here we'll have 40 combination 5. Now if we want to calculate this, I'll come over here to Excel. 40C5, 40 combination 5. So there are 658,008 possible tickets to buy. One of those is a winning ticket. So the probability of winning, 1 divided by 658,008, or 1 divided by 658,008. So, as a decimal, you know what? If this happens, if Excel gives you a number in scientific notation, we can go up here where this little drop-down menu is. This is the format of the display, and we could change that to just a number, and we're going to need some more decimal places. Okay, so 0.0000152. 5 zeros, 1, 5, 2. Very small chance of winning. For part B, let's see, you'll get twice your money back if you match 3 of the 5 numbers. If you buy 2 tickets, what's the probability of matching 3 out of 5? Well, let's figure out what's the probability if you buy just 1 ticket. If we get that probability, we could double it because you're buying actually 2 tickets. So, the probability of 3 correct, 2 wrong. Well, this looks like a situation where we will use the fundamental counting rule again. We could break this process of picking 5 numbers up into 2 parts. How many ways could you pick the 3 correct? How many ways could you pick the other 2 which would be incorrect? So of those 40 numbers, there are 5 correct numbers to choose, and there are 35 incorrect. So of those 5 numbers, we're choosing 3 of them. And for the second step in the process, of the other 35 numbers, we're choosing 2 of them. So how many ways can we pick the 3 correct numbers out of the 5? How many ways can we pick the 2 incorrect numbers out of the other 35? And divide that by total number of tickets, which we got in part A. That's the 40 combination 5. So let's see what we got. Okay, so we need 5 combination 3. That's 10, and we need 35 combination 2, which is 595. Okay, so we're at, let's change it up here, 10 times 595 over the 658,008. So this will give us the probability of winning if you buy 1 ticket, and then we'll have to multiply that by 2 because we're buying 2 tickets. Okay, so let's see. We have 10 times 5, 95. And then we're dividing that by 658,008. So that's the probability of choosing 3 correct. And let's take this number and double it. So 0.018. We can leave it at that, 0.018. 0.018. So that's the probability of winning twice your money back if you buy 2 tickets. Okay, and part C. So same lottery, but to celebrate 4th of July, there's a $1 million bonus if the numbers are chosen in the order which they were drawn. That means now order matters, so this is a permutation. So what's the probability of winning if we need all 5 numbers in the correct order? Again, there's only one way that could happen. One winning ticket. Out of all the possible tickets you could buy, which is 40 permutation 5. So in part A, we had 1 divided by 40 combination 5. In this case, order did not matter. And now for part C, we're switching to order does matter, $1 million bonus. So probability of winning 1 divided by 40 permutation 5. And what is 40 permutation 5? Let's pop over to Excel. 40 and 5. So this looks like 78,960,960. $960,960. So a much smaller probability than in part A. And let's convert this to a decimal. Okay, we're done with this. So let's say equal 1 divided by this number, 0.0000000, 7 zeros, 1 3. 2, 3, 4, 5, 6, 7, 1, 3. Okay, that does it for number 4.